What is motion? Well, the other day we discussed this. This is the universal movie, and we have on the top the static concepts, the main static concepts. At the bottom, we have some of the primary and some lesser or more sophisticated dynamic concepts. So at the top, you have dynamic static concepts such as object, distance, location, and existence. And on the bottom, you have things like motion, position, ether, field, etc., energy, time. And so we separate the static from the dynamic concepts. What is the difference? Well, static concepts you can see in a single frame of the universal movie. All you have is objects standing still, distance one from each other. All they have is location. All we have there is existence, all static concepts. What do we need for dynamic concepts? Well, we need at least 2 frames of the universal movie. That's what we're synthesizing here with this image. Okay. So as you can see, motion is at the bottom. It requires, according to this, 2 frames of the movie. You cannot see motion in a single frame of the universal movie because a single frame only contains a cross-section of motion. You could say a cross-section of time, meaning location only, and distance between, or distances between every atom in the universe. That's all we have in each frame. Okay, so that's our starting point. But it turns out that motion, some people try to define it now for hundreds of thousands of years, or so it seems, at least a few thousand years, and they haven't been able to define motion. And in order to get a handle on this issue about motion, we have to go back to at least the days of the Greeks. And probably, they got a lot of that stuff from previous civilizations, but we have to start with the Greeks because they did leave some kind of record that we can relate to. I just can't seem to think that that's where it all started. There probably were previous generations or civilizations that, already discussed what motion was, and a lot of geometry and a lot of the concepts that the Greeks somehow heard and then developed even further. So we have to start with the Greeks. And one place to start, that because they dealt with this issue in some depth, okay, they came up with new concepts, were the Eleatics. The Eleatics were a group of, they called them philosophers, they still call them philosophers, that were in the southwestern part of Italy. The Boot, they were on the southwestern part, and I created this little chart to give you an idea where the different schools of the Greeks were, and we're going to concentrate today on the Eleatics. And here it is. Okay, here you see the map of the Mediterranean. Some of these other schools, which are not pertinent today, you can see them circled there. But we're going to look at the Eleatic school, and specifically at Parmenides and Melissus. Okay, and they lived in that region of Italy, southwestern part of the Boot, and they had a great time coming up with new concepts. And one of the ones that they analyzed was the word motion. What is motion? Is there motion? Is there change? Okay. And one thing about Parmenides, is that he wasn't able to figure out something. He wrote a poem. That's all we have from him. And then the rest were analysis of Parmenides by Aristotle. Okay. But when you look at Parmenides, he wrote a poem. They call it today On Nature, because there's several of these poems and so on, books that they wrote in the past. They had no name, so they call them all On Nature. Okay, so Parmenides supposedly wrote On Nature, poem in which he put his ideas. Okay, and one of the things that Parmenides says is that he cannot imagine something moving in opposite directions. Okay, like you have a ball, right? Well, the ball can't move in opposite direction. It moves one way or the other, one direction, right? But not 2 ways. Okay, it can only move one way. Okay, and this is how he says it. This is from his book or his poem. Parmenides says, "Undiscerning crowds in whose eyes all things travel in opposite directions." Okay, those are undiscerning crowds, right? "For this shall never be proved, that the things that are not are, nor let habit force thee to cast a wandering eye upon this devious track, or to turn thither thy resounding ear or thy tongue, but do thou judge the subtle refutation of their discourse uttered by me. Yeah, he could not conceive of something traveling in opposite directions. It took 2,000 years, 2,000 plus years, 2,500 years almost, to come up with the rope model. Okay? Yes, there is something that can travel in opposite directions, but it's not a something. It's a signal that goes along a rope because it hits both ends at the same time, or in opposite directions at least. And all it has to do is twirl in place. And so you have a little bit drilling here and a little bit drilling there. You have drilling on both sides. You could say that's traveling, even though there is no traveling. Okay? But you have impacts on both ends. Okay? And so, yeah, in a way, you could say it travels in opposite directions because that's what light does, even though light is both a thing, which is the mediator of light, and the motion it does, which is twirl in situ. But you have detection at both ends. So in that sense, you could say, yeah, light travels, quotations on that, in opposite directions. But he could not figure it out. Okay, he didn't realize that his grandmother's clothesline was traveling in opposite directions. Okay, so what did Parmenides say? Well, he's credited, okay, of saying the following. He says, void, because he's going to explain that motion doesn't exist. Okay, so that's going to be his argument. It says, void doesn't exist. Nothing doesn't exist. There's nothing there, so it doesn't exist. Okay, whatever exists means, but he just took it for granted. He said the void doesn't exist. An object cannot move into what doesn't exist. You know, you have an empty space. It can't move into an empty space because the empty space doesn't exist. There's nothing to move into. Literally, nothing to move into. So therefore, motion doesn't exist. Okay, that was his argument. Not, okay, so we scratch it out. No, that's not what his argument was, but that's what a lot of people think today, that Parmenides' arguments, what his argument was. That was taken up by someone else. What Parmenides argued was something else. This is what he argued. He says, you know, motion demands a starting point. Okay, you have to have a place where you start. Okay, nothing exists before the beginning, before that starting point, because that is your starting point. So there's nothing before that. In this case, nothing meaning a something, right? Before nothing, before that starting point. Okay, beginning implies what? Creation of matter. If you're going to have a beginning, you have to have creation of matter. That's the beginning. You know, like Big Bang. How did the singularity get there? Well, we don't know, but they start at the where the singularity is already there. What surrounds the singularity? What is the singularity? We don't know. We don't care. You know, all they say is that's where we start our film. And that's more or less where Parmenides is going with this. He's not really talking about motion, as we will see. He's talking really about change. Okay? And I always say that change and motion are synonyms. There's only a tiny, very tiny difference between them, and I'm going to get to that in a second. Okay? But let's continue here. This implies that matter had to have a beginning, because that is your starting point. But creation, you know, from nothing, ex nihilo, is irrational. You cannot conceptualize how something, you know, how a rabbit pops in from the void surreptitiously. So you cannot create something from nothing with or without God. Because even, let's assume God exists. We'll move the magic wand. I'm going to be God for a second, if you don't mind. You go poof, right? Abracadabra, and suddenly you have the rabbit. No problem. How did you make it? What's the process? Give me what assembly line did you use to create the rabbit? Okay, what was the process, the mechanism? And if you can't answer that, well, you know, I don't even think God can answer that. Okay? You can't just say, well, it just popped in from nothing. Oh no, if nothing converted to something, right? Then you created something. There was some kind of motion, right? You would think, right? But he says it's irrational. You cannot conceptualize it. And I think he's right, okay? So therefore, motion is impossible. Okay? You cannot conceptualize motion because it has to have a starting point, and the starting point means the creation of matter, and that's irrational. That was his argument. Okay? That was Parmenides' argument. Okay, but what was he talking about? He was really talking about change. Okay, and here let me illustrate what I'm referring to and why change is not exactly the same as motion. Okay, why? Because motion, we think of one object. Okay, we think of one object as moving. Change does not necessarily, 100%, 99.99999, many 999s is the same. But there's one instance that I can think of at least where it's not the same. Okay, and that is when you have absolutely nothing and you simply make a change and have something. So it does involve, as we will see here, it does involve the universal movie. In one frame you have absolutely nothing, okay? And in the other frame you have something. Did anything move? Did the ball move? Well, not really. It's not that the ball moved from one location to another. What we see here is that there's something and suddenly you have appearance. And that existence, coming into existence, can we call that motion or is that just change? Okay, so we see the difference here between change and motion. Okay, but this is an extreme scenario. It's the only one I can think of. Maybe you can think of another one, right? But here we can see that change involves coming into existence, whereas motion is one object in two frames of the universal movie. You could say that, okay? That's a way of putting it. Okay, the person who actually talked about moving into voids was Melissus, who came a little after Parmenides. And this is what he had to say. And for this, he had to create the notion of what is known as the one being, you know. So he's talking really about the universe, okay? What he's going to say, his argument is going to be that the universe is completely filled with matter, you could say, and space, okay? And that's a little tricky here. But since it's all filled, not only in space, but in time, it's everything. And if everything is filled, then there can be no motion because everything's taken up. And so something cannot move into where something else is. Push it aside because everything is completely filled. The universe, the one being. Okay? So he said, whatever has a beginning and end is neither eternal nor unlimited. Okay? So he's going to start with this notion that of time. Okay? Being has no beginning or end. Okay? No beginning or end. Therefore, it is eternal and unlimited. He's talking about the universe. He's going to call it the one. He's going to call it being. He says it occupies everything, which already is a problem because if it occupies everything, what is on outside of it? And he's saying there ain't anything outside of it because it's eternal in time and it's infinite in space. So whatever that means, because we don't understand what infinity in time and eternity in time and infinity in space means, but this is what he's saying. He's filling up everything. Okay? And so therefore it is eternal and unlimited. What is temporarily unlimited. That's what is. Okay? Therefore, nothing else temporarily unlimited could exist at the same time, because this is everything. God, the universe, whatever you want to call it, okay, it's everything. And if that's everything, there can't be another thing if that's everything. So forget about multiverse, many universes. No, he says this is everything. Okay. What is spatially unlimited. So it's not only temporally unlimited, but it's also spatially unlimited. He just made the universe everything in space and time. Okay, just covers everything, whatever everything is. Therefore, nothing else spatially unlimited could exist at a different time. Okay, again. Therefore, what is one. Okay, now you got to this one, this notion of one that he wanted to get through. Okay, now he's going to proceed with a one. Okay, I hope you're following what Melissus is trying to say here. Okay, here's the one. He says, whatever undergoes change is altered. Okay, yeah, I think change and altered are synonyms, right? Okay, so he says, the one, meaning everything, universe, being, whatever you want to call it, God, right, is unified and whole. It's everything. Therefore, the one does not undergo any type of change because it's already filled. It's in both space and time. It's completely covered, right? To be empty is to be nothing. Okay, whatever empty is, because empty is a synonym of nothing. Nothing is a synonym of empty, vacuum, space, whatever you want to call it. What is nothing does not exist. Okay, they all had the same idea. Nothing does not exist. They never defined the word exist, but they said, oh, you know what I mean, nothing doesn't exist. Okay, something only can exist, whatever that is. Okay, the one exists. Okay, now he's saying that the universe exists. The everything, the eternity and the spatial infinity, that exists, right? Therefore, the one is not empty. Okay, the everything is not empty. Okay, this is his logic, if you can call it logic. Okay? But this is how we started this whole mess. Okay, and so here he continues. He says, "What is not empty must be full." Okay, so yeah, sounds logical there. It says, "Therefore, the one is full. The universe is full. Whatever has motion is not full," because he's going to say that motion is going to mean that you're going to move into a place or a region where there's nothing, okay, but it's all full, so there's nowhere to move. Whatever is full has no empty spaces, must be motionless. The one is full, therefore the one is motionless. Okay, you see how he went through all this? So what is Melissa saying? You say, the universe is full. There's no empty space because empty space does not exist. Therefore, you cannot talk about motion because in order to have motion, you should be able to move into nothing, but nothing doesn't exist. Therefore, there is no motion. This is his reasoning. So in the case of Parmenides, we're talking about change. We're saying it's motion also in general, but he's talking about primarily change, something coming from nothing. And in the case of Melissus, he's saying you can't move into nothing because nothing doesn't exist. Everything's full, therefore there is no empty space into which to move. That's how they're reasoning, and that's how we started. Okay, so here we have this all came a little later, Aristotle. And he's going to attack the notion of motion as well. He says, nature, a principle of motion and change. Notice that he separates motion and change. Like otherwise he would say a principle of motion or a principle of change. No, he says motion and change, meaning or suggesting that they're not exactly alike, whatever he means by change. And again, I think what they had going through their mind was this notion of appearing from the void, coming into existence. Motion is supposed to belong to a class of things which are continuous. Okay? Infinite is often used in definitions of the continuous. What is infinitely divisible is continuous. So he has a strange notion of what continuous is. He says continuous is what is something next to each other. So he's saying continuous is what's chopped up into pieces, especially numbers. He was thinking of numbers. Okay? So he said one next to the other, that's called continuous to him. In physics, we have a different notion. Continuous is that which is made of a single piece. But he's saying continuous is that which is exactly the opposite, segmented or partitioned, but one is next to the other. Because again, he's thinking of numbers. Okay? It says place, void, and time are necessary conditions of motion. Well, I'm not going to discuss place and void, but certainly time is not a necessary condition for motion. It's the other way around. Motion is a necessary condition of time. Time is the comparison of two motions. Motion you move, as we will see, if you occupy two locations. So no, we don't need time to define motion, and that was one of his big errors. Okay? And here we see he tries to define what motion is, Aristotle. Okay? He says, the fulfillment of what exists potentially is motion. He had two notions of motion. One is the potential and the other one is the natural motion. One is the motion that an object has by itself. He was thinking of gravity. You let go of the pencil and it doesn't stay up there. It has motion all of its own, natural motion. And then the other one is that while you hold the pencil, it has potential motion, which materializes when you let go. Okay? Then it falls. Okay, so this is the notion that he had of motion. What is alterable, what can be increased and its opposite, decreased, right? What can come to be and can pass away, and what can be carried along, meaning locomotion. Those are the notions of motion that good old Airy had 2,200, 300 years ago. Okay, hundreds of years later, another fellow attacked the notion of motion. What is motion? That was Rene Descartes. And he made a big mess of it just like everybody else. Okay, he never figured it out, but this is what he had to say and how he justified it. He says, motion is nothing more than the, what? Action? I thought action was motion. By which a body passes, I thought passes was motion, from one place to another. Oh, great. I guess he broke his head on this one. He's defining motion as motion. Let's replace action passes with motion. It says motion is nothing more than the motion by which a body moves from one place to another. That's what he said. But how does he justify it? Well, he justified something else. He's giving you here a little clue on how he's reasoning this. It says the same thing may be said to change and not to change place at the same time. So how can that possibly be? It says, so also we may say that the same thing is at the same time moved and not moved. Okay, how does he justify this? He says, a person seated in a vessel which is setting sail thinks he is in motion if he looks to the shore that he has left and consider it as fixed, but not if he regard the ship itself, among the parts of which he preserves always the same situation. In other words, you're in this little cabin on a boat, right? And you don't move with respect to the cabin, but you're moving with respect to the shore because the boat is moving along the water. So he's saying you move and not move at the same time. You're moving with respect to the shore, but you're not moving with respect to the cabin. Okay? Moreover, because we are accustomed to suppose that there is no motion without action, and that in rest there is the cessation of action, the person thus seated is more properly said to be at rest than in motion, seeing he is not conscious of being in action. Again, that's what happens when you introduce observers into your discussion. That's why we kill observers in physics. We do it mafia style. We wipe out the witness, because that's what happens when you introduce observers and you talk about observation. You're observing that you're standing still, but your observation is wrong because you're moving with respect to the coast. Okay, so are you moving or not moving? Well, both. I'm moving with respect to the coast, but I'm not moving with respect to the cabin. And so they end up with these contradictions saying, well, you move and not move at the same time. And why? And because of that, they end up with the wrong notions or the wrong definitions of what motion is. And here we have another guy who gave it a try and failed miserable. His name is Isaac Newton. Some of you know him. Okay? And he talks about place. Okay? And place to him is not the same thing as position. Okay? He's going to make a tiny distinction there. Place is a part of space which a body takes up. It's what we call position. Okay? Or at least in physics. Position is the same thing as the object. The object itself is position, because it's like the fish is in the water and it displaces water, the volume of water that the fish displaces. So is that true in space? The fish occupies space, meaning it occupies that volume, displaces something? And the answer is no, because space is nothing, and so the fish does not displace anything. Therefore, the fish is at the position itself, because there is no displacement of any material entity when a fish occupies space. When it occupies water, yes, there is displacement, but not in space, because space is nothing. Okay, so it says, and is according to the space either absolute or relative. I say part of space, not the situation, nor the external surface of the body. For the places of equal solids are always equal, but their superficies, by reason of their dissimilar figures, are often unequal. And then he clarifies here that there's a little difference between place and position. Positions properly have no quantity, nor are they so much the places themselves as the properties of places. Okay, so I think he's referring here to the Cartesian coordinates, fellow who came before him, right? And so it's like the ordered pair is the position, which is what mathematicians call today position, right? And place is the physical, supposedly, volume occupied by the object. So you have to think of it in those terms. So what did Mr. Newton conclude after thinking so deeply? Well, he concludes the following. He says, I do not define time, space, place, and motion as being well known to all. So he never defined motion because he had no idea what motion was. And yet he's credited with discovering the 3 laws of motion, which is not true either, because Descartes and Galileo already had talked about the 3 laws of motion of Newton. Okay, so what is motion today? What have we learned from all these great luminaries, right? And here it is. This is the definition we have today. Motion, the action. Ring a bell? Or process. It looks like those 2 already have motion. Of moving. Oh, I love that one. Motion is moving. Okay, I always wanted to know. Or of changing place or position. Movement. Great. We've learned a lot. So what is action? Well, the process or state of acting or of being active. What is a process? A systematic series of actions directed to some end. A continuous action, operation of or a series of changes taking place in a definite manner. What is moving? Capable of or having movement. Great. I love all these definitions. They're all synonyms. Movement, the act or process or result of moving. What is change? To make the form, nature, content, future course of something different from what it is or from what it would be if left alone. Meaning that all of these are synonyms. All they said is motion is motion. Motion means moving. Motion is movement. We learned a lot with that. Motion is action. Motion is a process. Yeah, so they have no definitions today. You will not find a definition of the word motion, a scientific definition of the word motion in any textbook of physics at the high school or college level ever on planet Earth. Okay? So we don't know what motion is because they defined it using synonyms, and when you look up those words, you find out they all contain the word motion. That's where we're at today. So let's find out if we can find out what motion is. Okay, here it is. Motion, 2 locations of an object, right? You need 2 frames of the universal movie. Now here, the yellow dot, ball, whatever you want to call that, is gauged with respect to the position, the location, right? Is gauged with respect to the frame of the film. But the way we have to look at this is that an atom, any existing atom, simply has distance with respect to all other atoms in the universe. Okay? And so there's distance between them, and when that distance, in other words, in the next frame of the movie, locations change of every atom in the universe, now you have motion. You have 2 locations. That is the definition of motion, and not the action or the process or whatever other synonyms people put it in there. Okay, so let's see if we can find out how these definitions come together. Here it is. Object, that which has shape, not that which you can see or touch. Distance, separation between objects. We're talking about physics here. So what we're looking at, separation, that's distance. Distance is not unrolling the measuring tape and counting meters. That's not distance. That's distance traveled of the end of the tape, or how many tiles you put between 2 things. That's already, that's motion. That's dynamic. That's a dynamic concept. Here we're saying distance, just separation. Gap, okay, chasm. Location, the set of distances from one atom, for example, to all the other atoms in the universe. Okay, now you have distance, set of distances. And motion, 2 or more locations, 2 locations of an object. That's how they come together. Now we have a definition that you can sink your teeth into and not have to rely on synonyms as they have been using for the last at least 2,500 years.